Welcome to the class. In this session we are going to see the topics like load curve, basic definitions and some problems related to the load curve. First we are going to see what is a load curve. The curve showing the variation of the load with respect to time is called as load curve. So in a load curve we will be taking the load on the y-axis and the time on the x-axis. So the load curve shows the variation of the load during different hours of the day. So for during morning 6 o'clock, what is the load? During evening 6 o'clock, what is the load? In the noon, what is the load? For different hours of the day, it will be showing what is the particular load required. This is called as load curve. The area under this load curve will represent the total number of units generated in the day. And from the load curve we can see what is a base load and peak load. Base load means it is the load available throughout the day is called as base load. And peak load means during the particular hours, particular time, the maximum demand will be required. That we will say it as a peak load. Different types of load curve. The load curves are classified into three things: daily load curve, monthly load curve and yearly load curve. Daily load curve means it shows the variation of load during the whole day. Monthly curve means it shows the variation of the load of the month with respect to time, and it is obtained from the daily load curve. Next is the yearly load curve. This yearly load curve is obtained from the monthly load curve, and this curve shows the variation of the load of the year with respect to time. Next curve is the load duration curve. So this load duration curve is obtained by arranging the load elements of the load curve in the descending order. Magnitude of the load should be in the descending order. This is the example of load curve, and this is the load duration curve. This load duration curve will be obtained from the load curve. So here if you see in the load curve for different hours, we will be marking the different power demand. In the load duration curve, we are going to arrange in the descending order. So what is the peak first in descending order means it should be a highest. So the highest power demand is 2 megawatt, and from 8 o'clock to 16 hours we are in need of this 2 megawatt. So totally for 8 hours this 2 megawatt is needed. So from 0 to 8 hours we have to mark this 2 megawatt. Next demand is 1.5 megawatt, and the time for that 1.5 megawatt is from 4 to 8 hours. So 4 hours we are in need of 1.5 megawatt. So from 8 to 12 we can draw this 1.5 megawatt. Next demand will be for 0.5 megawatt. So 0.5 megawatt initially some 4 hours, and then at the end of the day from 16 to 24 hours we are in need of 0.5 megawatt. So here 8 hours, here 4 hours. So totally 12 hours from 12 to 24. Total 12 hours we are having a 0.5 megawatt demand. So we have arranged the load in the descending order, magnitude of the load in the descending order. This is the load duration curve. But the area in both these curves will be the same. When we measure the area in both these curves will be the same. From the area we will be able to know how many number of units are generated in the particular day. Now we are going to learn some basic and important definitions related to the load and the load characteristics. First we are going to see what is a connected load. So number of electrical equipments connected to the system, we will say it as a connected load. The load can be in terms of watts, kilowatt or megawatt. Next definition will be the maximum demand. During a specific period of time, what is the maximum demand required? That will be the maximum demand. In short we can say it as the greatest demand of the load during a given particular time is called maximum demand. Next is the demand factor. This demand factor is obtained from the maximum demand. So demand factor is given as the ratio of maximum demand to the connected load. The value of demand factor is always less than 1. Next definition is the average load or the demand load. So these things they can ask you in 2 marks. You have all these formulas will be useful for your solving your problems. The average of the load occurring on the given period is known as average demand. We are going to take the average. So daily average means it is the number of units generated in a day and by the total hours. Daily means it is 24 hours. So we are going to take it as 24. Monthly average means number of units generated by hours in a month. Hours in a month means totally we are considering it as 30 days. So 30 into 24. Next is the yearly average load means for the whole year. Total number of units generated in a year divided by what is this 8760. Totally how many days in a year? It is 365. So this represents 365 into 24. Next is the load factor or the demand factor. Load factor is obtained as the ratio of average load to the maximum load. So this average load, if you are knowing the load, average load and maximum load, you can use this formula. If you are knowing the total number of units generated, then you can use total number of generated means you can use this formula. Here, what is this T represents? It represents the number of hours. So for a daily load curve, it is 24. If the given question is, they are giving you the weekly load curve, then it is 24 hours into 7 days. For yearly load curve means it is 24 hours into 365 days. So all the definitions will be interlinked. If you know the maximum demand, if you know the how to find your average load, then only the next things, next formula you will be able to implement. And also this load factor will be always less than unity, and if the load factor is high, then the cost of each unit generated will be low. Next definition is the diversity factor. Diversity factor is obtained as the ratio of sum of individual maximum demand to the maximum demand of the station. What is this individual maximum demand? So each and every group, if it is industrial load, it will be having some maximum demand. If it is a domestic load, some maximum demand. Commercial load, some maximum demand. So each and every individual maximum demand we have to sum it and then divided by the maximum demand of the power station. That gives you the diversity factor. Always the value of the diversity factor will be greater than 1. If the diversity factor is higher, the cost of generation will be low. Previously we have seen about the load factor. The load factor value should be lesser than 1, and here the diversity factor should be greater than 1. You have to know all these things. Okay. Next definition will be the capacity factor. So capacity factor is obtained as the average ratio of average demand to the rated capacity of the plant. This rated capacity and the plant capacity are one and the same. In certain places they will be giving you the rated capacity, certain places they will be giving as plant capacity. Both are same. Okay. So from this formula only we have obtained this formula. Average demand is the ratio of units generated by number of hours. So from this only we have obtained this formula. So this is your capacity factor. This will be the utilization factor. It is the measure of utility of the power plant capacity, and always its value will be less than unity. It is the ratio of utility factor is the ratio of maximum demand of the power station to the rated capacity of the power station. Next is the plant use factor. So this gives how effectively we are using the power produced in each and every plant. It is given as the plant use factor is given as the ratio of total number of total number of units generated to the product of the plant capacity and the number of hours. The last one will be the reserve capacity. It is the difference between the plant capacity and the maximum demand. From the name itself we can identify reserve. it will be always useful for the emergency condition. So it is also a generating capacity which will be always available during emergency condition. You can take this reserve capacity. Now let's solve some problems. So this is the question given. So in the question they have given you the maximum demand is 100 megawatt with the load factor as 40%. Then calculate the total energy generated. So for all these things we have to recollect the previous formula. We know the formula for the load factor. It is the ratio of the number of units generated to the maximum demand. So from that formula we can obtain this. So the number of units generated or the energy generated is equal to the maximum demand into the load factor into the total number of hours. So when you multiply all these values, maximum demand, load factor and the hours, it is given as the in a year. So your hour will be 24 into 365. When you multiply, the product will give you the result. In this example, we are going to find the demand factor and the load factor given the amount of connected load and maximum demand and the units generated per annum means in a year they have given you. So these are the things, these are the given details. If you know the formula, you can directly apply. The demand factor formula will be the maximum demand to the connected load. So maximum demand is 20 megawatt and the connected load is 43 megawatt. So you will be able to get the answer. Next is your average demand. Average demand, it is in the question they have given you per year. So the units generated per year by hours in the year. So unit generated is 61.5 into 10 power 6 and hours in a year means it is 24 into 365. So you will be getting this value. And load factor, it is average of ratio of average demand to the maximum demand. In last problem, previous problem, we have used the load factor as the ratio of units generated by maximum demand into time. So for whichever required based upon the given details in the problem, you have to use the formulas. So you have to memorize all the formula. All these definitions are very important. Any one of the problem will be coming from the unit 1. Concentrate on this. If you see in this problem, this is the question and they have asked you to find the annual load factor. And in the question they have given you the station works for 100 megawatt for 2 hours and 50 megawatt for 6 hours and remaining period is the rest period. So for out of 24 hours your power system, your particular station is working for only 2 plus 6, 8 hours only it is working and it is given as 45 days of maintenance. So totally we have 365 days, out of that 45 days of maintenance. So we have to remove this 45 days from while calculation. And in this problem for solving all these things we have to go in the reverse order. First we have to know what is the load factor. Write the formula for load factor. So this is the formula for load factor. So you know it is the ratio of units generated or energy supplied in the year. The question they have asked as annual load factor. So you have to consider it as per year divided by the maximum demand and the into total number of hours. So total number of hours we have to consider it as 24 into, it is not 365, we have to take this 365 minus 45 because 45 days is going for maintenance. The system, the power plant will not be working. So it is 365 minus 45, so 320 days. So it is 24 into 320 the working hour. Then maximum demand, it is given the question 100 megawatt plant. You can take that or else for 2 hour if you see out of 150, 100 is maximum. So take that maximum demand as 100. Then comes to the numerator part, it is the total number of units generated or the energy supplied per year. So we have to calculate how many, what is the units generated. So in the question they have given you 100 megawatt for 2 hours and 50 megawatt for 6 hours. So unit supplied for per day will be 100 into 2 plus 50 into 6. So its unit will be 500 into megawatt hour. So all these units should be unit of each and everything. If you are in machines and all, you will say you have to put your voltage, V, current, amps, those units. Similar to that, this megawatt hour, all these units should be is important. And your station will be operating for 320 days. So the energy supplied per year will be this energy supplied each day into number of days. So 500 into 320 will be 160000 megawatt hour. So when you substitute all these values in the formula, you will be getting your final answer. Go through this example. In this problem, they were given you the maximum demand as 25 megawatt, load factor 60%, plant capacity factor 50%, and plant use factor. They have asked you these details. So for each and every problem, as we said earlier, we have to take the write down what are the given data and what are the things to be fine. Only if you summarize all these things, you will be getting the idea to use which formula and how to apply. You have to all the formulas. If this problem is going in depth, you will not be getting all the values directly, right? Only if you write all these required things and all the formulas in the side, then only you will be able to replicate, get an idea how to solve the problem. So write the formulas. In this question, the first subdivision is to find the reserve capacity of the plant. So reserve capacity of the plant is the difference between the plant capacity and the maximum demand. Your maximum demand is 25 megawatt. It is given in the question. It is a given data. So you have to know the plant capacity. Plant capacity formula is the average demand by plant capacity factor. We don't know, plant capacity factor is given in the question as 50%. So when we convert it, we have to take it as 0.5, and the average demand we don't know. This average demand we are obtaining it from the load factor. Only the load factor is given in the question, load factor and maximum demand. So from that we can obtain the average demand, and when you substitute, you will be getting your plant factor. Plant factor is the ratio of average demand by plant capacity factor. The second subdivision they have asked is the daily energy supplied, that is the number of units produced daily, right? So its unit will be the megawatt hour. So from the average demand we can find, average demand formula is average demand is equal to the energy supplied, that is kilowatt hour supplied in a day divided by 24. That will be our average demand. So from that formula we are obtaining the daily energy produced. So average demand is given in the question and 24 hours, so it is 360 megawatt hour. The last thing they have asked is the what is the maximum energy that could be produced in a particular day. So it is obtained, this value is obtained from the plant use factor. So plant use factor, in the question they have given you the input data is the plant use factor. From the plant use factor formula, plant use factor is equal to the energy required divided by the actual energy supplied. So by substituting the values you will be getting. So you will be having an idea to use which formula. Only if you write and see each and every formula, and from the given data you have to write the given data to find all these things and write. If they are write all the formulas only, it will be easy for you to analyze and proceed to the formula, proceed with the problem. Consider this problem. Here we are having 3 consumers and they have given you for different time period what is the load demand, load required by different consumers is being tabulated here. And in the question they will ask you to draw the load curve. In certain question they will ask you to draw the load duration curve also, and these are the maximum demand, load factor, all these things is the given question. Here if you see second subdivision, load factor of individual consumers, and last subdivision it is the same load factor of the whole station. Let's see how to solve all these things. In this example, we are going to find the demand factor and the load factor given the amount of connected load and maximum demand and the units generated per annum means in a year they have given you. So these are the things, these are the given details. If you know the formula, you can directly apply. The demand factor formula will be the maximum demand to the connected load. So maximum demand is 20 megawatt and the connected load is 43 megawatt. So you will be able to get the answer. Next is your average demand. Average demand, it is in the question they have given you per year. So the units generated per year by hours in the year. So unit generated is 61.5 into 10 power 6 and hours in a year means it is 24 into 365. So you will be getting this value. And load factor, it is average of ratio of average demand to the maximum demand. In previous problem, we have used the load factor as the ratio of units generated by maximum demand into time. So for whichever required, based upon the given details in the problem, you have to use the formulas. So you have to memorize all the formula. All these definitions are very important. Any one of the problem will be coming from the unit 1. Concentrate on this. Next subdivision they have asked you is the diversity factor. Diversity factor is the ratio of sum of individual maximum demand by maximum demand on the power station. This maximum demand is obtained from the load curve. From the load curve you can identify this maximum demand value, and sum of individual demand is the maximum demand of consumer 1, maximum demand of consumer 2, and this will be the maximum demand of consumer 3. The ratio of this will give you the diversity factor. The last thing they have asked is the load factor of the whole power station, but this formula remains the same. It is the number of units generated for the day divided by the maximum demand into the time period. So, time period is 24 and maximum demand for the whole power station is 2500 as we see in this case, and this energy consumed or units generated is based on each consumer. So, it is 600 into 6 for last power factor we have calculated, right. So, this will be the energy consumed by unit 1, energy consumed by unit 2 and energy consumed by unit 3. When you add and divide it, you will be getting the total load factor of the whole power station. So, you have to go through all these problems. It is one of this problem type is one of the important problem which they are asking repeatedly in the university exam. I have given 3 assignment problems, so it will be of different types. Try all these problems and solve the problems individually. Before coming to the next class, submit this assignment. Thank you.